Hello everybody, I am Corrado Gioia Carabellese, Product Development Specialist at Frascold. Today I will present a performance analysis of a commercial all-in-one CO2 refrigeration system, considering possible improvements in different climates. First I will give you a brief overview of our CO2 compressors range. Then I will present a case study describing the monitored system and alternative configurations. A numerical model has been developed and then used to run seasonal simulations. Finally, I will show the result of these simulations comparing the COPs of different configurations and cities. Frascold is a leading Italian company that has been operating for more than 80 years in the world of refrigeration and air conditioning, producing and marketing compressors all over the world for a wide variety of applications, such as commercial refrigeration, process cooling, and industrial refrigeration. Our product line includes screw compressors, condensing unit, and reciprocating compressors, using both standard and natural refrigerants. Today we will focus on the latter, talking about subcritical and transcritical CO2 compressors. Our range of subcritical CO2 compressors reaches displacement over 800 cubic feet per hour. We currently offer 11 models divided in 2 and 4 cylinders, all characterized by very high standstill pressures. The figure shows the application envelope of our subcritical CO2 compressors with evaporating temperatures between -58 and +14 degrees Fahrenheit and condensing temperature up to 68 degrees Fahrenheit. The main benefits of these compressors include reliability, thanks to the use of resistant materials, appropriate surface treatments, and an adequate lubrication system. They are also characterized by high efficiencies, with a low oil carryover and the possibility to operate in a wide range of frequencies using an external inverter. Our range of transcritical CO2 compressors includes 33 models, up to 6 cylinders, reaching displacement over 1,600 cubic feet per hour and motor size up to 50 HP. All models are suitable for handling the high pressures of these systems, with very high operating and standstill pressures. Two different motor sizes are available. The first, motor 1, allows the highest operating pressures, more than 2000 psi and 68 degrees of evaporations, which are very common, for example, in heat pump applications. The second, motor 2, is more suitable for less critical applications, with operating pressures up to 1600 psi and 41 degrees of evaporation. Compared to subcritical compressors, transcritical compressors feature 3 piston rings instead of 2, and they also have a noise scraper. This allows to achieve higher efficiencies at higher pressures with a very low oil carryover. A mechanical capacity control is also available for Model D and Q-TK. Both subcritical and transcritical compressors are also equipped with an electronic protection and diagnostic module. They are also characterized by very low vibrations. A case study with our CO2 compressors has been analyzed. The purpose is the theoretical investigation of an all-in-one CO2 system for commercial refrigeration, considering also possible improvements in different climates. A numerical model has been developed and used to run seasonal simulation and compare the annual performance of the systems. The configuration considered in this study is installed in a supermarket in northern Italy, located outside Milan. This benchmark configuration is a booster system with parallel compression and some internal heat exchangers. It meets the cooling demands at two different temperature levels, with evaporating temperature of -27 and +16 degrees Fahrenheit. The CO2 system fits the hydronic circuits for sanitary hot water production, space heating, and air conditioning. This two-stage heat recovery requires the production of high-temperature water, affecting the performances of the system during the winter time. An external evaporator is placed in the same framework of the gas cooler, at the same pressure level of the empty evaporators. It works during the winter time, when the heat recovery is needed, absorbing a thermal heat flux from the outside and with no useful effect. Some alternative solutions have been analyzed to increase the performances of the benchmark configuration, that is booster system with parallel compression, considering overfed evaporators, vapor ejectors, and evaporative gas cooler. The first one is a booster system with the parallel compression and overfed evaporators at both medium and low temperature levels. The liquid separated in the medium pressure receiver is expanded to the low pressure level, and an internal heat exchangers allow to avoid liquid droplets at the compressor suction. In this case, overfed evaporators allow to increase the evaporating temperature compared to dry expansion evaporators. The second configuration integrates overfed evaporators and vapor ejectors, which suck the vapor at the outlet of the medium pressure evaporators and reject it at the intermediate pressure level, recovering part of the expansion work. The third configuration integrates evaporative gas cooler instead of a standard one. This solution allows to decrease the refrigerant temperature at the outlet of the gas cooler below the outdoor level, reducing the flash vapor separated in the intermediate pressure receiver. The fourth and last configuration integrates all the benefits of the previous ones, so overfed evaporators, vapor ejectors, and evaporative gas cooler, with the external evaporator at the intermediate pressure. A steady-state model has been developed, and some results obtained from the monitoring of the system have been used as boundary conditions. The number and the type of compressor are the same of the monitor system, with one compressor of each group equipped with an external inverter. With overfed evaporators, the evaporating temperatures are increased by 9 degrees compared to a standard solution with dry evaporators, and both vapor ejectors and evaporative gas cooler are enabled when the outdoor temperature is above 68 degrees Fahrenheit. Each configuration previously described has been first assessed using the climate of Milan. The thermal loads are obtained considering the nominal capacities reported on the left, with air conditioning and space heating active during daytime from 6 am to 9 pm. In the specific case of the cooling capacity, a weekly load profile has been defined and a correction factor considered, proportional to the external temperature. The simulation results show that overfed evaporators allow to bring benefits all year round, increasing the performances for all the outdoor temperatures, thanks to the higher evaporating temperatures compared to dry expansion evaporators. The use of vapor ejectors and evaporative gas cooler helps to further increase the performances in the summer period, but the benefits are low with relatively low outdoor temperatures. In the last few years, we have also internally developed a free tool dedicated to CO2 that allows us to perform seasonal calculations without, for example, the need to use third-party software. We have then used our software to run seasonal simulations in 3 different cities, Milan, New York, and Los Angeles, considering the most effective configuration among those presented, so booster system with parallel compression and overfed evaporators, and making the assumption of a 24-hour supermarket, so with air conditioning and space heating always active. As shown in the table, the highest performance is achieved in Los Angeles, with a yearly average COP of 3.5. In conclusion, a model has been developed to simulate the energy performance of an all-in-one CO2 system for commercial refrigeration. The model has been then used to evaluate the performance of alternative configuration using the climate data of Milan, New York, and Los Angeles. Overfed evaporators proved to be the most effective solution since they allow to increase the COP for all the outdoor temperatures, while vapor ejectors and evaporative gas cooler are effective only for high outdoor temperature. Simulating a 24-hour supermarket, the two-stage heat recovery affects the performance of the system, and the highest COP is achieved in Los Angeles. Thank you very much for your attention.